Physical properties of gaseous substances. We're now going to talk about substances in their gas state. These substances have no definite shape and no definite volume. Gas particles will fill a container, hence they will take the shape and the volume of whatever container they are filling, a balloon, a cylinder. Gas particles move with translational movement. This is a straight line movement that allows for many random collisions. This is why gas particles have the properties that they do. Pressure is a variable that can be measured. Its definition is a force exerted by gas particles that are moving and colliding with the objects in their path. That could simply be the walls of a balloon. Pressure is also defined as the force per unit area. That's more of a physics term. Its symbol is a capital P and its SI unit is a Pascal. 1 kilopascal is 1,000 pascals. Atmospheric pressure is the force that air exerts on all objects. 1 atmosphere, or ATM, is standard pressure, 101.325 kilopascals at 0. Brr, that's way too cold though to be working in a lab. So we use standard ambient pressure, which is 100 kilopascals at 25 degrees Celsius. There are other units for pressure that we'll look at a little bit, but aren't as big of a deal for us. We prefer to work in the metric system or the SI system, international system of measuring. The gray parts of this diagram represent liquid mercury. You can see how it moves in the tube. Charles' law of gas particles. Charles's law states that when the mass and pressure of a gas are kept constant, that the volume of the gas will change proportionately to how the temperature changes. This can be seen through graphical analysis with a straight line with a positive slope. The formula would be V1 over T1 equals V2 over T2. V is volume, T is temperature, 1 is initial, and 2 is final. Volume will be in liters, temperature is in kelvins. Kelvin is a different temperature scale. 0 degrees Celsius is negative 273 kelvins. This picture simply shows that as the temperature increases, the volume of the gas also increases. Solving a sample problem for Charles's law. Assuming pressure remains constant, a gas inside a cylinder with a movable plunger is heated to 315 degrees Celsius. The volume of the gas is 0.30 liters at 25 degrees Celsius. Calculate the volume of the gas in the cylinder after the temperature increases. To get a visual of the movable plunger, you may wish to see page 433, figure 10. You must state your given information. This is written on the left-hand side of the page. Notice that the temperatures T1 and T2 have been converted to Kelvin. This is done by adding 273 to whatever value you have in degrees Celsius. Writing down the formula for Charles's law, V1 divided by T1 is equal to V2 divided by T2. Substituting in the values and the units will allow you to rearrange the formula and solve for V2. Notice how kelvins cancel each other out. The final answer has been rounded to the correct number of significant digits.